Okay, I just wanted to make a short video with a few more examples of checking for symmetry. So here's an equation, 2xy equals 1. We want to check to see if this particular function, if we were to graph it, does it have any of the types of symmetry. So let's start out with checking for x-axis symmetry. Remember, with the x-axis symmetry, you replace y with negative y. Now 2x times negative y is negative 2xy equals 1. If you wanted to, you could try and do something with that negative 1. You could divide both sides by negative 1. But notice, in this case, we do get the positives. But now over here we have a negative 1. So no matter what you do, we are not going to get back to that original equation. So it does not have any x-axis symmetry. So now let's try for y-axis symmetry. In this case, you replace x with negative x. This is going to become negative 2xy equals 1. Now we're at the same place we were before. Really the issue is we have this negative here. If you try and get rid of it by dividing or multiplying both sides by negative 1, all that does is it moves it from the left-hand side to the right-hand side. But once again, it's not the same as the original equation. So the answer here again is no. And finally, let's try this for origin symmetry. In this case, you're going to replace both of them. When we multiply the two negatives, this becomes a positive 2xy. And look at that, we are back at the same equation. So this one is symmetric to the origin only. Okay, let's try another one. I'm going to go through the same steps here. So we're looking, does it have x-axis symmetry? For x-axis, you change y to negative y, or you replace y with negative y. Now again, notice at this point some of you might recognize it's not going to have that x-axis symmetry because of that extra y. But if you need to, go ahead and we can multiply both sides by negative 1 if you want to try and simplify it. I'm going to sneak in, see if I can sneak in the negative 1 there, sorry. So that left-hand side is going to become a positive y. The right-hand side is now negative x cubed plus 2x. So we definitely did not end up at the original, so it does not have x-axis symmetry. Let's try for y-axis symmetry. This requires a little bit more work. We're going to replace x with negative x. Now when you cube something, let me show you this in between step. We are multiplying it 3 times. That's going to become a positive 2x, negative 2 times negative x. We're multiplying it 3 times, and negative times a negative is positive, times another negative is negative. So we get a negative x cubed plus 2x. Again, notice not the same as the original. So this one is a no. And finally, for the origin symmetry, I'm going to replace both of them. Now the good part about this one is you've done most of the hard work. We already simplified the right-hand side on the previous problem, and we said this is going to be negative x cubed plus 2x. So I'm not going to show you all of the steps. Let's use what we already did. Now both of them, because of the negative here, let's see what happens when we multiply both sides by negative 1. On the left-hand side, we get positive y. On the right-hand side, that becomes a positive x cubed and a minus 2x. And if you compare that to the original, yes, it definitely has origin symmetry. Okay, let's try this one. Again, I'm going to start with x-axis symmetry. You can do it in whatever order you want. For the x-axis symmetry, we replace the y with the y squared. Now let me show you what you might want to do is utilize parentheses, because that y is going to get replaced with negative y. I think I just said y squared. And then we're not doing anything to the x for this one. Remember, when you square a negative, I'm going to write it out for you, it's negative y times negative y. Those two negatives make this a positive y squared. So we ended up with the same equation. So yes, this one has x-axis symmetry. So let's try for y-axis symmetry. You replace the x with negative x. And again, if you need me to on the right-hand side, I will write this out 3 times. You don't have to do this, but some of you were just getting back in the swing of things. It's been a while since you took a math class. So the 3 negatives end up negative, and the x times x times x is x cubed. Definitely not the same. Now notice how the left-hand side is the same. This is the same. We've talked about this multiple times now. If I try, this right-hand side has this extra negative. If I try and do something to get rid of that negative, so for example, if I try and multiply both sides by -1, it's not going to change, it's going to change things. It's going to change the way it looks, but now the right-hand side matches, but the left-hand side does not match. So when you just have that extra negative, there's really not anything you can do to get rid of a negative. So let's now do origin. For origin, you do both of them. And based on what I told you today, I know it's not going to have origin symmetry. It either has no symmetry, one type of symmetry, or all 3, but let's go through the work here. So for origin, we replace both of them. When you square a negative, it becomes positive. I went through all those steps a minute ago. When you cube a negative, it stays negative. 3 negatives are a negative. Notice again, I'm going to stop here. This is the same, but the right-hand side is not. And trying to move the negative to the other side is going to change the other side. So at this point, I forgot to write no down here. We can stop, I think, and say no symmetry to the origin, no symmetry to the y-axis. Okay, let's do one last one. Again, I'm going to start with x-axis symmetry. For that, I replace y with negative y. Okay, now I could actually stop here. Notice the right-hand side is the same. This extra negative right here is a problem. Let me just, based on what we talked about today, I just want to show you what happens if you were to multiply both sides by -1. I'm going to sneak that in here if I can. Sorry, not a lot of space, so let's put it right here. So I'm running out of space here. Now, on the left-hand side, it becomes positive y. Let me just remind you of our conversation earlier. The negative, you can put it in front. Again, not the same, at least not the way it looks like. Or you can put the negative on top. Still not the same. Or you can move the negative to the bottom. Now, if you're going to move the negative to the bottom, you need parentheses because there's 2 terms in the bottom. And what you would have to do, or what you could do if you moved it to the bottom, is rewrite this as -x plus 1, or if you prefer, 1 minus x. None of these look the same as what we started with. So the answer here is no. Let's look at y-axis symmetry. So this time I'm going to replace x with negative x. Whoops, that's squared. When I square the negative x, it becomes positive x squared. And on bottom, It's not the same. We have this extra negative down here. Now there is one thing you could do to this if you wanted to. You could factor the negative out. Notice that's an x plus 1 if you factor it out. And then once again, typically we don't write fractions with negatives on the bottom. We could put it on top. That's a common place for the negative. Still not the same. We could put the negative out front. Still not the same. We do not have the original equation. So this is also a no. Finally, let's look at origin symmetry. Now remember, most of the work has been done for us. So I'm going to leave the left-hand side as it is for a moment. When we square negative x, we get positive x squared. Now notice we have an extra negative on the left-hand side, so I'm going to factor a negative out of the denominator. Now, then I'm going to bring that negative up top, because typically that's where we put our negatives, and this should be a plus 1. Sorry about that. Now, you could try multiplying both sides by negative 1, so let's try that. These two negatives become positive, so plus, plus. These two negatives also become positive. But notice they're not the same. This one has a minus, ours has a plus. So this is also no to origin symmetry.